we have 2 Rocket Lab pieces of news, which is awesome. We really do love Rocket Lab. It's a great company. They've had their struggles like every space launch company. SpaceX is obviously the most popular, the one that we talk about the most here. But Rocket Lab, SpaceX has also had many failures. In fact, they're one of the best at failing and then coming out of it succeeding. And Rocket Lab had a huge, huge win on their latest launch. There and Back Again was the name of the mission. Great Lord of the Rings reference. But they launched their Electron rocket, delivered the payload to orbit successfully, and they attempted to recover their first stage rocket for the first time. They had talked about this move to switching towards reusability, and one of the things they wanted to do, because, how SpaceX does it, where they're able to control the descent of the rocket, but then also for the thing like the drone ship, you need to fail at that a bunch of times to get to the point where that can be a fully reusable thing, and really against all the industry that was there before it for the most part. Didn't believe that was even possible to do in the first place. Never mind make a business around it. But Rocket Lab has taken a slightly different approach, which I think is awesome. Rocket Lab was using a Sikorsky helicopter to grab the first stage rocket of Electron after it had deployed a parachute. So you've got I'll use our Falcon 9, our resin Falcon 9 here, but they had a parachute carrying the first stage down as it was coming down, and then the helicopter came in and grabbed it and held it, and they had to eventually drop it because of how much drag was on the helicopter for something like that, which is a crazy thing to think about, and shows the sheer talent of the pilots that were able to do that and know enough to drop the rocket. But they gathered a ton of really important data for whether or not, they probably spent a bunch of time, money, effort trying to dial in like how possible is this to even do, and if we get it right, how is this going to make a business case for it and help us recover these things, but then also to do it and actually get the real data. There's so much value to that, and that's one of the real lessons that I think SpaceX kind of retaught the space industry from the early Mercury, Apollo days, that it's like, in order to get something as grand and amazing and influential and efficient and important as the Saturn V rocket was, and the Apollo capsule and command module, like, it took many failures, and that history has already been written from the early NASA days, and SpaceX showed the same thing. And Rocket Lab is also, they hit a bunch of mistakes that obviously they weren't expecting, and no one ever does, but they changed it up. They switched it up and said, we need to make some really big moves. And of course they talked about Neutron, which is going to really be their truly reusable rocket. But now they're going to go this whole other way with Electron, and I think it's beautiful. I thought that was amazing. I can't wait to see more attempts of helicopters catching rockets. I mean, that's the best. I mean, that, as far as aerospace goes, that's amazing to give another purpose to a helicopter. And then those pilots, right? How many pilots are now potentially people are gonna become pilots now because they're gonna see someone catch a rocket with a helicopter? It opens up our minds to so many different possibilities we never really thought were possible before. When we see it actually happen, thinking it is one thing, dreaming it is another, but actually seeing what it does in real life, when the rubber hits the road, it's the best. You can't beat that. And Rocket Lab, in May of 2022, they're supposedly launching the CAPSTONE satellite. So what we're going to do, we're going to pull that up. CAPSTONE is an important spacecraft for the Artemis program. It's one of the pieces for the Gateway. And the Gateway is this idea of making life long-term in space. In order to do that, having stations at all these different places where we're going to want to go from going really fast to controlled descent down to a planet or a surface. That's what the Gateway is going to allow us to do, is give us these little parking stations where we can go to safely transition from travel place to place to descent from orbit down to the planet. We do the same thing with the International Space Station today, right? We launch stuff up, it docks to the station, they spend time up there, then they undock and come back to the planet. When you're going to the moon, you're going to be traveling extremely high velocities, because that's what got you to the moon in a reasonable amount of time in the first place. And if you're dealing with gravity, the way to slowly come down is to match orbit with something else, dock, and then you can take a separate spacecraft specifically designed for landing from the station down to the surface. So it becomes a much safer, much more repeatable, way more redundancies for traveling in space, where, if we just sent any kind of spacecraft to the moon, that's just not how it works. So CAPSTONE is really important. It's expected to arrive at Mahia Launch Complex in New Zealand in the next few days. This was an article written by Rachel Hoover on May 10th. The CAPSTONE spacecraft is the cislunar autonomous. Okay, I'm going to say this correctly this time. I can read it, I promise. The cislunar autonomous positioning system technology operations and navigation experiment, or CAPSTONE spacecraft. And it's going to chart a new path, as they say, for NASA's moon orbiting space station Gateway. And it just started, so May 9th, it shipped from the Terran Orbital Corporation in Irvine, California, to the launch site at Rocket Lab Complex LC1, and that's in Mahia Peninsula in New Zealand. So our folks in New Zealand, cheers. You guys have an amazing launch provider with Rocket Lab, and that location is beautiful. So look forward to that. That's a huge mission. And if we go into CAPSTONE a little bit here, again, these missions will be here. What is CAPSTONE? CAPSTONE is a microwave oven-sized CubeSat. So again, this is the technology that I did my major qualifying project in school. CubeSats, really tiny spacecraft that could fit in the palm of your hand in some cases, but miniaturized, just like our phones went from being these giant things that operators need to design that had tons of mass and weight, just like our TVs, right? They all miniaturized. CubeSats is that progression for spacecraft that don't need a lot of space and allows us to launch more things into space. Backtracking, CAPSTONE is a microwave oven-sized CubeSat weighing just 55 pounds, and it'll serve as the first spacecraft to test a unique elliptical lunar orbit as part of the cislunar autonomous positioning system technology operations and navigation experiment as a pathfinder for Gateway. And CAPSTONE will help reduce the risk for future spacecraft by validating innovative navigation technologies and verifying the dynamics of this halo-shaped orbit. So this is something that we've talked about with other guests here on the podcast. We'll throw their episodes up here if you guys want to go listen to them. But the message that we're getting through here is that we have all this interest in space and we want to do all of these things, but the infrastructure, the things that would be there that are there for our airliners, right? What makes it possible for us to fly as quickly and as often as we do, and as cheaply, even though it's not cheap, as cheap as it is for the everyday person to fly around the world. The infrastructure that's in place to do that safely, to the point where people aren't, there isn't a statistical reason for people to be worried about flying airplanes. We do not have that for space travel. We just got our own country, America's ability to send human beings into space. And to think that we're just going to make the jump towards space being something that's very easy for us to do and repeatable and everyone can do it, a lot needs to get put in place. And things like this, like CAPSTONE, are absolutely huge. And trying out these new different orbits, it's allowing us to test all this stuff to know where everything actually is, so that by the time we start unleashing the amount of things we want to launch into space, especially around the moon and the Gateway, we'll have an idea of how to know where everything is. So we don't have things colliding with each other, because that's bad.